Hi, this is Haisheng Wang, and today we're going to talk about Pacific Atlantic water flow. And given the M by N rectangular isolated board, there are some rules about the water flow, which mean that the cells can only flow to its neighbors where the current cell's height is greater or equal than the neighbor's cell's height. And we're supposed to return the coordinates which the cells can flow to both Pacific Ocean and Atlantic Oceans. So for this of the problems, like just show in the example one, for the 2 here, it can flow to the Pacific Ocean because 5 is greater than 4 and is greater than 2. So it can flow to the Pacific Ocean. And 5 is greater than 1 and 1 is equal than 1. So it can move to this one and then move to Atlantic Ocean. So, and if we try to solve this kind of problem, I prefer to just start in the opposite way. We just start from the boundary of the matrix like this I showed here, and use 1 denote for the Pacific Ocean, and we try to color it along the way, and also use the 2 denotes for the Atlantic Ocean, and use the 2 to color the cells along the way. And there will be some bit operation here. If the status of some cells is to be 1, and if we try to color it with 2, and it will be like 1 and 2, and we'll just get 3. And this is just the same if we original one is 2 and we try to color it with 1. It will just like 1, 2, also get 3. And the initial value should be 0, and 0 to this OR operation for 1, it will got to be 1. And if it's just a 2, and we'll just got a 2. So let's just write some main functions here. So hide all that, and also, yeah, this is the shape of the matrix, and just construct the same size status denotes for the status of each cells. The initial value should be 0. So this is a list to store the result, and then we should first define DFS. And there are 4 parameters. The first 2 is just the coordinates of the cell, and this denotes for the previous values. This is used for check the valid path, and this is color we try to status we try to color the new cells. So first we just I0 minus 1 1. Copy that. This line of code denotes for we start from the first column, and this line of code denotes for the last columns of the matrix. And because if we start from the first column, the status we try to color is just 1, denotes for the Pacific, and similarly 2 for the Atlantic. And we used minus 1 here because every cell has a positive number. So in the first round of the DFX, it will just will not go into the base case, so we can get the correct result. Similarly, we should go through the first row and also the last row. After doing that, we can just return self.is, and then we'll just finish the DFS part. And there are maybe three column case, base case here. I will write first and then explain. The first column case is that if the ij is out of the boundary of the matrix, we will just return, and it's easy to understand, I think. And the second column case is that the current height of the cell is less than the previous one, which means that the path is not valid, so we just return. And the third column case is a little bit tricky. This actually means that the state ij, the first is equal to the c. So this kind of the bit operations will get a positive number. This means only if the two digit has the same value, it will return 1. The second is that if the status is just equal to 3, so we should not consider to continue our DFS functions. We can just return. And for this one, because they are already same with the current status is just equal to the status, we try to update it, so there is no need to continue our DFS function. So these three column cases here. Let's see, we just updated the status, and if the str is equal to 3, just append it to ij, and go its neighbors. We just copy this fourth one, plus 1. This is just its neighbor or its neighbors of one cell, like this one. And this one, if the original is just 1, and we try to call it with 2, and it will gotta be 3. And just it's similar if its original is 2, and we try to color it with 1, it will color this 3. And if the original is 0, and if we try to color it with 2, it will. If we try to color with 1, and it will be 1. I think it's just similar if we try to color it with 2, and it will get 2. Yeah. I hope this will work. Yeah, I think it's work here, and this example is really hard to explain. Actually, I just record this problems for 3 times, and it's and I hope you understand what I'm saying here. Thanks for watching.